Hello there. Hi, Funky Waddle. Congrats on first. So it's supposed to be... and I have no idea what to start with. As always. All this. And here. Actually, why is that is right. Hey. Still gonna make it quieter because feels like the music is too loud to me. 65, 70%. Okay, good. I should also use Control L. It's a useful shortcut. Okay, so we crash on not yet implemented in declare. What else? Oh right, data types, arrays and stuff. A bit of meat. It's fine. To be honest, I don't know what meat is. Anyway, so where is this? That's front end, right? Line 34, let's do this. And let's see. An array type. Yeah. Oh right, it's gonna be so tough. Well, C has an array type, right? I guess let's read about it for a little bit. Honey wine. Yeah, that makes more sense. Oh wait, I might know what it is. Not that I have ever seen it in my life, but I heard of it. Anyways, so we need... Also, am I pressing Control K and it does the same thing as Control L? Oh, exactly. Wow, I did not know that. Well, it's probably different, but it's just random. Randomly, a coincidence. Anyways, so, C arrays, or array type. Because in C++ there is actually std array, and I'm pretty sure that's exactly what I want, but I'm not using C++. Same semantics as start holding C style. Exactly. Does not decay automatically. That's what I want. Oh my god. I'm gonna have to do structs manually. Well, I mean, that means generics and tuples are on the way. Okay, so harder parts. We hit harder parts in our compiler stuff. We're preparing for this, right? Arrays, tuples, and similar. Let's do the tuples first. Because I kinda need generics. Well, actually, no. Arrays are fine because to the front end they are just a type, so it would be just what does array hold? LSP restart. It might LSP like when I try to hover, it says no hover results available. That's not true. It's just LSP didn't load. Well, I mean that is kind of true, but that's weird. Array, come on. Oh, and now see, it doesn't show this message. Because hover results are available, they just take a while to load, apparently. I guess. Okay, so if I, oh wait, that's not what I need. Oh no, no results are available. Oh, why? Well, the speed's just broken. Huh. And now it's loading. Okay, BTS array, so it's gonna be type, or actually, what is it? Convert type. Something kinda like that. I can do this. Yes. Okay, so LSP is loading. We'll wait for it to load, I guess. Or... oh. It's done. It's not working. I actually wanted to check rustc. Well, I mean, I guess I can do that. It's up to date. Which means it is there, it's just not working. Does it compile? I mean, it should. I mean, it doesn't because, like, yeah, methods and variables do not exist. But oh, hover appeared. Let's go. Okay, ty and const. Ty size. So I need something to evaluate the constant. Assuming it's not generic. Because it might be generic. Well, let's hardcode the size to 42 to do use size, because that's another tangent. Might just spend the whole stream on arrays, actually. An array self size. Oh wait, ty type size. So you see this Rust file. That's just an example from Rust by example. Commented out some lines that yield errors, obviously, and commented out some lines that do not work yet. And also added a lot of drops because Rust Analyzer apparently wants to optimize everything away. Although with drops it doesn't. And then if we run test, which is a script that just runs the compiler twice, once to compile... wow, everything lags. Once to compile Orco, which is what I'm working on, and the second one to compile this file with Orco as a backend. You can see that, well, Orco doesn't compile, but that's beside the point. If I comment this out, and also comment this out, it should run, and it should panic actually. Oh wait, I commented the wrong thing out. It's temporary. And if I comment out this, then what we're gonna see, a lot of warnings. Oh, and the compiler still panics. Oh, wait, did I? Oh, I did. Okay, hold on. Might just comment this out and replace this by do here. Now this should work at least. Here, so you can see it spits out the C code that was meant to resemble this Rust code. It inlines some variables. That's just what Rust does. You can see the MIR representation here, which is something difficult to read. Oh, also generics, I completely ignore those. Some literals, variables, more things, yeah. That's about it. So it basically just converts Rust to C. And then we'll do more cool things with that. So that should return type. Should I actually do this or well, actually maybe I don't, and maybe I just do type. Since this is clone but not copy, we'll do array of type, use size for size, and array type. T array size. Yeah. Oh, and right, we need to box it. Cycle detected. My compiler would have just crashed out of recursion, right? rustc is at least smarter. Okay, so now instead of this, we could just drop it in type array box that. Oh, here we go. Autocomplete's pretty slow. Also, yeah, I should do this so they have full screen width. Now backend side. Here we need type array. Here. You are right. In fact, that's Super Mario 2007 from Super Mario Galaxy. Which surprisingly sounds, I mean, unsurprisingly, I guess, sounds exactly like original SMB theme. Okay, maybe not exactly, because original was a little bit. Wait, actually, might not be original. Wait, no, this is original. Well, yeah, Nintendo just uses the same song in multiple games. That's fine. Okay, so if we imagine that we live in the perfect world. From TY. Alright, I can't really use recursion. Can type to string y or could type return string, and then here we'll do. I'm gonna take this. We'll just do self of type to string ty, so that recursion is easier. Don't have to wrap, unwrap, and other things. So don't have to wrap this. Don't have to wrap that. Type to string. My keyboard is likely extra loud. Alright, well, actually no. Roll back. Nah. Okay, let's format it. Format. Is it like that? Can I? Okay, no. This. Then we do ty equals. And then we wrap this. Then we add size. Oh wait, I don't need a dollar sign, that's Rust. Not JavaScript or anything. I mean, I guess I could just do size here. No size here. Oh, actually, I don't even have to do this. As ref. Okay. So yeah, about the music, I normally run Super Mario Galaxy soundtrack in the background, and then when it ends, it just plays 12 hours of copyright-free music, some random video from YouTube. Okay, so that would work if we if C language was actually better. All right, this is Orco type. To distinguish different packages. New size, yeah, sure, I know. Missing docs, yeah, sure, I know. Okay, so. Oh, wait, right, simple. Oh, right, it's gonna be a while until we'll be able to, actually, wait, no, we can. Wait, we can generate it. Unfortunately, this is not gonna work. Oh, I wish this would. I wish this would work. I so wish. Chat remove. Oh wow. Thank you for the 56 bits. Yay. We've reached 2 to the power of 7 bits goal. Thank you so much. Wow. I probably should well, first of all, I should pause this. I probably should work on more animations for goals and stuff. Yeah. So this obviously doesn't work. Yeah. C is not ideal. Pointers would. Well, arrays would. Like that. But that's not quite correct. Because it's just gonna be a pointer. So what we're gonna do is array struct x. We're gonna do something like that. And we're gonna do struct array int x 42, for example. Oh my god, that's gonna generate a struct for every single size. Alright, let's see. Type def struct this. So this would work. Hold on. Back. Also, oh, I know why it broke. Well, no, I don't. But Chatry did actually break. Is it still alive? I mean, it should be, yeah. Okay, one more thing to fix about the overlay. So we're gonna do this, and oh my god, that's a lot of moves. If instead of this we do type def int 42, I assume it would be this. Wait, no, it wouldn't. This. Yes, this is not gonna work. Oh wait, you can't return arrays from functions like that. Int. Thank you. Let me look. I assume this doesn't work. Although... Oh, wait. Right. Although knowing C, it might. Okay, yeah. That would be weird if it did. um... Oh, wait. No way it actually parsed. Who declared as a function returning an array? Oh, wow. Well, I guess, sure, okay. Um... That is weird, and obviously this is not supported. Oh my god. Wow. Anyway, so we'll need to do this, which means we'll need to do interning. So a single declaration backend. Let's do this, cgen, declare. Okay, so we have function signature, we have declaration backend, right? For backend. So backend is gonna have should I use an interning crate or something? Why? So what we need is generics first of all. Well, regular generics. So intern generic name and type parameters and get out the concrete type. Same thing for well, basically same thing for tuples, except that type parameters can vary in size. So what do we do with this? Let's try. How do we generate generics? So let's look at the declaration backend. So declare function, for example, would take generic parameters. And then, so for each symbol, because we have, so we split every impl or anything into symbols, and that means generics would propagate to each symbol. So every symbol is gonna have generics, and when I say declare function with generics, that means wrapping the name. So I need to create a wrapper with a name that function uses, and then call this wrapper to generate the function, and then call the generated function instead. Yeah. That is pretty confusing, but that's about how it's gonna work. Okay, so for now we won't do generics yet, but we won't do generic API. What we will do, however, is generics in the backend. So hi programmer Jeff. Yeah, emotes don't have flashes, which I guess is something that I could do. But there are many plushes, including this one. Yes. Okay, so exactly. There are many. There are like There are 179 flashes, which obviously doesn't include many streamers. Many streamers that I watch. But yeah, it includes quite some streamers, which you can pick streamers to find some. Wait, pick, here. Oh wait, right. I need to click first, because that's how it works. So yeah, you can pick, you can do that multiple times, and yeah. You can also catch plushes and get on the leaderboards and many more things. Which reminds me that I need to add a label here, saying what this leaderboard is actually. Okay, so for generics, well, we have declarations. You need to catch this plushie. You do need to catch it. Just as an explanation, any plushie spawned with a plushie command is considered wild and it's gonna disappear after like 30 or 60 seconds. However, if you catch it, for example, I caught myself and then spawn it, it's not gonna disappear. That is pretty confusing, but like, there is also help. Yeah, not very helpful, but I guess. Is there help for plushie? Oh right, there's your Twitch connection stuff broke. Oh, that's sad. Team. Yeah, none of the help messages really help you with anything. Anyway, so your Twitch connection broke. Twitch connection stuff broke. You can, I guess, regenerate tokens and do authorization flows again. Okay, so assuming this houses generics inside, so type parameters within the symbol or something. Or I could bundle type parameters into a struct. I mean, I have signatures here. Declare. Okay, let's go here. Let's do struct declaration. Also, let's add some docs. Primitive types. Houses implementation of. Do I really need? Wait, why is this even public? Question. Get rid of that. Thank you. See you. Okay, so yeah, right. TY. What is TY? Oh, right. Well, I don't necessarily need it as a public module either, because it exposes a public type, which is what matters. And documentation should be put on that type. Literally just a wrapper around a string for holding a type in sealant. Well, I mean, I guess I could use worker types instead, but like, the point is, Orco types have... I mean, I don't really need to... Well, if I hold Orco types, I could... So if a type is generic, I could, for example, get generic arguments one by one separately. Whether in this case I will... Since I'm storing a string, I can't really... without parsing it. Which I don't want to. Type just appears construct and would not appear in the source code. Check if the type is void. I mean, yeah, there is story behind this. Default implementation, from implementation, format implementation. Yeah, right. Nothing really to see here. Code generation, declaration. A symbol. Enough to create headers. To generate function bodies. Yeah. All for inclusion. So this is important. Which for some reason, I mean, I guess if it's public, then it would work. Yeah, it's not public. Hidden code generation. Instruct for code generation session of a single function in about a variable within function code gen. Actually, here it might work if I do this. Yes, it does. So that, I mean, looks kind of correct. So yeah, those are mainly explanatory, self-explanatory. This is just codegen, nothing really to see here. Central backend. The for entry. C backend. I also, so we did this here. I don't need the thingy. Just I don't know what the convention is, but it seems like seems like those thingies are used for types with paths. I assume that's just how Markdown works. Okay, so declarations. Oops. So this is gonna house the declarations. Okay. So this is gonna be item declaration. Body string. So it might have. Wait, body. So it might have function signature. Back of type and string for the name. Optional, I guess. Okay, so here we have a declare function. So we create a function signature. I mean, it's just storing it basically somewhere. High thinking void, or unique, right? Early. Yeah, because it's weekend. I normally just, well, I mean, I was supposed to be doing early streams on weekend. So yeah, that's what I'm doing. Because I have time in the morning, on the weekend, as opposed to any other day. Okay, so we can do this. Parameters right. So it just, I mean, is it copyable? Oh, it's copyable. I mean, this is pretty. Impl stdfmt display for declaration. So I guess I could cache the name. Oh wait, no, name is there any point in caching the name? Make it public. Public in declaration kind. So no semicolon also. I guess I could import both. So they are used for definitions later on. That's why I'm not storing them as literal strings. Okay, so since we added that, derive, clone, debug. I mean, do I need the queues? I guess. I guess I could. So type should definitely have all the traits, right? It does. This, I mean, this can have a queues and orderings, I guess. Does it make sense to order function signatures? Like put them as a keys in the map? That's like the question. So EQs are for comparing if they're equal. Makes sense. Orderings and hash, to me, I would derive those when this type makes sense to use as a key in a map or dictionary, whatever. So yeah. does it make sense to map function signatures to something? I mean, no, honestly. But should I keep it? Actually, as hash. So if not only the map, those can be used in a set, and then it makes sense. So yeah, justify it. Let's go. So kind. Let's implement missing members. Yeah, let's create the primitive type mod function. Use function signature. Function rest should just work. Right. Use super type. It literally put a comma at the end of the line. At the end of the statement. Something's wrong with me. Okay, so function. I guess I could close this for now. Escape could go into declare, but nah. No, declaration kind, declaration backend. Yeah. Declare function, I mean, I guess we would just do is there debug assert? There is debug assert. I mean, it's not that expensive, so I guess it's fine. Actually, well, maybe it is quite expensive. Maybe it is. Should we declare stuff in parallel? Because, like, it makes sense. It is. If you have thousands of functions. I mean, spawning threads. Wait, no, it does make sense to actually declare stuff in parallel. So maybe. Maybe we parallelize it. And then it's gonna be annoying to deal with in backend, but like, it's fine. So we have a map. A log-free. We need a log-free map, and then we need a log-free collection, set, whatever, multi-set, unordered anything. Let's search for a log-free map. Hi Nigel. It took you 47 minutes to join the stream. You've missed so many things. I mean, not that I've done anything on stream in those 47 minutes. Except for rambling about how annoying CRAs are. One as a backend. I mean, actually, maybe I've tried. Yeah, I've tried also to do rustc driver. So two. And then we also hacked Rust Analyzer, but that doesn't count. Also moves a little bit to the corner. Here. Okay, log free hash map. Can we do it in Rust? Obviously we can. Log free. I mean, there is log free create. BRB water. Okay, you actually use BRB. Great. Okay. Hydrate. Thank you for the hydrate. Great, Sayo. Log free. Last updated 7 years ago. All-time downloads 1 million. What log free crate should we use? I mean, I guess this one, despite the fact that it was updated almost 7 years ago, and probably doesn't use... What is that? Ha. Also, hold on. I forgot to disable one thing. Welcome. Here. Because that's slowing down the internet traffic. Hi, Scott. Oh wow. This name. Vivendi. That, right. So, I wanna see documentation for the latest commit. Oh wait, that's GitLab IO. Wait. Oh, that's also GitLab, right? C11 implementation of incinerator. What? 6 years ago. Well, that's at least a little bit up to date. Why is the goal over? Today's, come on. No, it's over. Unfortunately. You had 1 day, and you did actually like you did actually get surprisingly a lot. 60%, but yeah. Better luck next time, I'm gonna say. Should I refund it right now? I mean, I guess I should. Can you, Nigel, actually refund it? Because you can refund redeems. I don't think it is in the same menu, though. But it would make more sense. Goal not met. Oh, there's extend and the trash again. Delete and refund. Here you go, your points are back. You've collected more than half, which, I mean, makes sense. You've collected 900 on top of, like, you and Devninia. You could probably get Penguin Operator on, and he would do 2k easily. And then... well, you could probably get 2k, like, collectively. I mean, actually, okay, 2k collectively is pretty unrealistic. Because you collected 900 collectively. You need some people who actually do lurk and watch to hit it. And I don't know if there are any. If there would be any left. Okay, so log free is not has not been used, or has not been updated in quite a bit. 6 years, 5 years. I mean, I feel like it should still work, but like no, whatever. Rust look free create maintain. Well, there's look free and look underscore free. I assume this would be maintained more. Oh, this is. Okay, this does look a bit better. So many emotes. Pretty surprising. Use cases for avoid high concurrency mixed push pop patterns. Use producer consumer patterns. Oh, well, I'm not using stack. I need hash map. 15 to 25 million operations per second, 250 million operations per second, parallel reads. Concurrent caching shared state. Well, that's exactly what we need. Skip list. 5 to 10. Skip list is slower than a hash map. Oh wow. Order collections, range queries. Well, I need something like that, but unordered. Is there a collection that I could lock-free insert into and just ignore the order completely? Yeah, so it's log dash free. Let's do that. Cargo and log free package or co-cgen. So it's time. It's time we actually upgrade to a log free data structure. Wait. Log free. Well, it's just log free hash map. Insert get. Well, that's exactly like regular hash map. Memory ordering. Is relaxed ordering or safe for maximum performance? Well, I don't care about ordering, honestly, except for so hash map should when finished. Yeah, anyway. No memory reclamations. I don't care. Again, I need performance. I want performance. I like performance. Hash map. So from symbol to declaration, right? Now, we're gonna get rid of this. Definitions are gonna be... I mean, we could do log free list. Do nor data struct would work better. Oh wait, it takes 2 generic parameters. What do you mean? What do you mean list takes 2 generic parameters? And this doesn't have a list example, of course. The one that like I don't understand. 3 millions Q stack hash map 10 to 30 kills with threads. Okay, so structs modules. Oh wait, there is no re-export, fast skip list, and ultra hash map. Hash map ultra. What is this? Ultra fast log free hash map using open addressing. Ultra optimized log free hash map with what? List of one log free list implementation. Simplified high performance log free skip list. Ultra fast. Why? More implementations, more variants. Collections. Give me that. Ordered set. A concurrent ordered set. So yes, that's what I want, but unordered set. And doesn't necessarily have to have one item. So it doesn't have to check one item. Guide recommended. Stack queue ordered collection performance. Have I ever used Hindley Milner? Do you not remember how I implemented it for the first time in Orco something version? Best. Oh, what? Concurrent map. And I'm just gonna allow us to skip. What? To skip list? Why? Okay, so this for later. I do not understand this crate structure. This model provides several of-1 list variants. Append only list. Of-1 append of-n search. Indexed list. Of-1 gets set by index. Fixed capacity. Unordered set. Of-1 insert remove contains using hash table. Okay, so this is kind of what I want, but append only list is probably better. Crate structure, new Rust feature. Exactly. Log-free crate uses a Rust feature that's in beta, not yet released, which is crate structure. Actually, Sordy uses that as well, and has been using for a while. I mean, okay, jokes aside, it's not a feature, but some people structure their crates in an interesting way, where you have literally modules specifically for documentation, and then this crate has like modules for. Well, I mean, sure, this makes sense, but it is so interconnected and and like interesting structure. Okay, so what we need? List O1. Append only list. Oops. YouTube check, because YouTube does not update. Defs, append only list of strings. Sure, that works. Default is not satisfied. Oh, there is no default. Wait, what? Oh, why is there no default? That's annoying. It's fine, I guess. Oops. We'll implement it manually. Actually, can I do? Yeah. Vehicles. Lock free. Hash map. New. And devs are gonna be lock free. List O1. Append only list new. No, I kind of want to swap those around. So this uses a self new. Doesn't implement debug. Oh, that's a shame. No, that's besides the point. So concurrent map, which uses skip list under the hood. Then there's also fast skip list. What is a skip list? Key value. Oh, what? Why was new in default? Well, so people use new when they construct something manually. Like hash map has new, for example, despite not taking any arguments there, and it has many new overrides with allocator, with anything else. And then default, so that you could use this struct and then derive default on it in order to get default implementation. That would just call the default constructor. So it's new for people, default for traits, basically. And you would normally hold on to that. Now, My question is why? Why is a list taking keys and values? I mean, I guess this is a list that's like of one insertion, of and search or something like that. There could be no, because those are the same implementation. Do you use hash map default when you construct a hash map? No, you don't. Like, also normally, if you have like construction logic, you would put it in new and then call new in default because new does stuff, and then default is just the new thing. And if you derive default, if you are able to derive default, you would in new call default the other way around. Well, because you want new, that would just be default. Although sometimes in that case you would not use new, because yeah. But I normally do because I like to. I like to call new instead of default instructs. Of log and skip list, whatever. So concurrent map uses a skip list, and that's the recommended map. Different implementations. It's also respecting external types. Huh. Most usually alternative queue implementation, FA based, extremely fast for producer consumer. Hazard stack with hazard pointers. Okay. Ultra high performance LCRQ. What even is this? And there is not a single place where you tell me what this means. I assume it's a queue. Original OFN linked list. Only used for small collections. A log-free ordered linked list implementation. Unbounded queue. Unbounded Michael and Scott queue. When you can't specify capacity. Okay, yeah. None of that is what I need, really. I mean, I found what I need already. Recommended concurrent collections for different use cases. So why are those recommended and then the log-free crate itself uses different ones? Whatever. Anyway, so I think we found the types. They're not perfect in any way. Is like log-free downloaded? Just 1,000 downloads. I mean, when was it released? Oh, it was released 4 months ago. Oh, there are just 3 versions. 0.1.0, 0.1.1, 0.1.2. And yet it's so great. Wait, and there is no GitHub repo, which is very annoying. Oh, there is GitHub link though. Activities, private repositories. Yeah, that's not very great. I hope this crate will get updates, right? I mean, there is quite literally no way to message them, except for writing issues on random repos. I'm still gonna risk and use it because this looks like a great library. Maybe it's a copy of something. Maybe it's like a fork. Might be. Queues. rustc 8 days ago. Ooh. Well, it also provides a lot of types. Yeah, however, it doesn't have the list. Anyway, I think we'll just keep using those structs. Debug, I guess I can't use debug, unfortunately. Well, in this case, I don't really care about unorderedness. Oh, this scared me. Hi, Penguin Operator. Welcome in. Summoned Game Maker. That's a rare thing. That's a rare drop. I feel like KD appeared multiple times. KD and Plasma. As like intro plushes, and then there are some niche plushes which like never appear. Name one. Try to name one. Decal. Actually, I don't mind the semicolon. Decal, then def. Oh, it's not an iterator. Oh, that's sad. Oh, well, there's into iter. Into future. But I can't even. Here, right. Of course, Rationalizer has not caught up yet. I guess we need to try compiling it. Not an iterator. Not an iterator. Yeah. Oops. And other things, well, we'll tackle them later. Also, I should do this. Oops, not that. Okay, so can I get into the struct? I mean, there are docs, I guess. Hash map. It's like so advertised. Take a look at source. Buckets, layouts, I mean, looks valid. Hash key. Oh wow, you just discard lower or higher or whatever. Let's go back here. Insert remove content key, len empty. What about iteration? Oh, there is nothing to iterate over it. Oh, that's bad. No, that's pretty awful. There's a way to get and remove. Cause like I don't really care about getting and removing, honestly. Of one append only list. Well, append only list has an iterator. Notable traits. Oh, a pointer. A const pointer. Well, that's bad. Yeah, maybe we choose a different crate. So we had which one? STC, I guess. Recent 8 million downloads, 29 million. Okay, that's a popular crate. Definitely. So I need a list. Actually, this might be a good one. Concurrent, although it's lockable. Is a 32-way associative concurrent cache. Okay, let's see. Examples. Hash map. If the key is unique, an entry can be inserted. The inserted entry can be updated, read, and removed synchronously or asynchronously. Entry synchronous. Well, I don't care about synchronously. Asynchronously. Give me the docs. Okay, structs. Re-exports back cache. I wanna know what the cache is. With hasher. Entry async, entry sync. This is basically just a cache map. Hash map. Try entry, put async. Yeah, what's the point? Oops. Okay, so we need hash map, I guess. Keep this open. Scalable concurrent hash map data structure provides for fast concurrent workloads. Non-exercised array of buckets. Okay. Non-sharded. Non-blocking resizing. Auto resize. Incremental resizes. No busy waiting. By the way, I should mention all the types I need are append only. Manipulation methods are linearizable. I have no idea what this means. Okay, so reserve entry async, entry sync. Try entry, begin async, begin sync. Any async, any sync. Oh my god. Insert async. Insert a key value parent into hash map. If the key exists, value is not updated. Upset async provides a way to update the value if key exists. Okay, so do I care? Well, I mean, no, actually I do need an entry. Get the entry associated with given key for in-place manipulation. Okay, and if entry is occupied, then we panic. Well, I mean, kinda need to lock it at this point. Entry sync. So you do entry sync and modify counter or insert. Okay, I guess let's try STC. Hopefully this has iterations. And imagine then just ether sync, ether async and deal with that. Ow. The SCC hash map, I'm pretty sure. So from key to value. I should just be able to do this, and then for a list, I have no idea. What should we use? Where's create list? Okay, so this explains a lot of things, right? Hash map, hash set, hash index. Read optimized concurrent hash map. Yeah, we don't really care about reading it. We'll still have to read it synchronously, which I guess means doesn't matter how you async it. Like, after all, you could just log everything. Hash cache. Tree index. Read optimized concurrent B plus 3. I don't know. What's wrong with my mouse? Why is it drifting up? See, I don't know what this means. Concurrent log free unordered opaque container. Wait. Concurrent bag is completely opaque. These allowing access to contain instances until they're popped. Well, that's not quite what I want. I don't care about popping, but I do care about so I need something to put stuff in and then be able to iterate over it. First in, first out, last in, first out. Is a trait that implements a log-free concurrent single list. What a trait? Atomic shared. Oh, what? Whatever. Bank. Tree index. Okay, what does tree index is? I guess key value as well, right? Cache. Those are all just maps. I mean, okay, hash set is not quite map. But value type is a unit. Basically. Okay, so what do we do? I mean, bag looks pretty similar, but it's not gonna allow reading, which is crucial. I mean, actually, is it? Okay, it doesn't open docs for the thing. Adnan 46, hi. The first message, hello, I'm from India. Like, why? I mean, sure, but every single person who comes in and is from India just wants to tell about that. Color game website hacking tips. I actually don't know what color game is, or maybe I don't remember. Oh, and I need to remember to be careful to click on YouTube because, well, I may accidentally ban people because YouTube is weird. Okay, I don't wanna do that. Yeah, I don't know. What do you mean? What was I doing? Alright, bag. I wanted to try opening bag. Close that. Huh? Thanks. So what I need is a bag. So a new bag, we push into it, and then we pop. And then we, and pop all. And fold them into an accumulator. That is interesting. Color trading. I don't know what this means. Debug drop. Okay, so from iterator. Wait, is there into iterator? Oh, there is. Mutable references. Oh, what? Also, back takes a rail-in. Well, I actually don't know. It will exceed it. The maximum value of is limited to U-size bits over 2. What? So in my case it's 32, since we're on 64-bit machine. Whatever. Well, it definitely exceeds. I know that for sure. I guess we could use a bag. And then here. How can I write? Decals. Wait, what was I about to search? Alright, I wanted to check hash map. Duplicate. Hash map. Iterators. That's what I want. Iterators, iteration, anything to iterate. Async. Ha! Stops iterating. Okay, sure. What is the difference between asynchronously and synchronously? Since you're using it so much, could you explain? Interfaces. SDD. What is SDD? It's another crate. Async. Blocking and asynchronous methods. Okay. Selected by read-write lock. Okay, so we could use the read-write lock, or we could use a regular iteration. So we need entry sync. Right. And here we... do we care even? I mean, I guess we... No, actually, no, we don't. Yeah, asynchronous is hard. Input future. Oh my god, it's an async function. Yeah, no. Intersync. I'm not doing async functions. Key value. I mean, website hacking tips. I don't know. I'm not a hacker. I mean, I did actually find some exploits on some websites, but all of that is just reading through the source code. So yeah, I know, if you want, you can just Google how to program, and a long way, and you're gonna figure it out. Let me think. Yeah, I'm starting to think that this is not what I am looking for. Oh, okay, first of all, I need a log-free map. Concurrent skip list, fast concurrent shared hash map. 7 years ago. Folklore. I think I heard of it. Not very popular. Oh yeah, no. That's not gonna work. Why is it so hard to find a log-free map? This is 4 months ago. 22k downloads. Two hash map implementations. This in hash map, which is a single-threaded hash map. Rust definitely does not provide that. A leap map, which is fast concurrent version of the hash map where all operations can be performed concurrently. High query counts, multiple codes. Well, yeah, I mean, I guess 19. What is a throughput? Like, relative. A million operations per second. RW log plus hash map wins. What? Oh wait, that's one core. 16 cores. Oh wow. Well yeah, leap map, I guess, something like that. Or skip list, which I heard, I guess. Recent updates. 1 hour ago, okay. That's not very well. Not goes very well. Skip linked list. Like, why is there no concurrent list create in Rust? Log free data structures Rust. Or use CC. What am I reading? We're building a log-free array. Okay, that is not quite what I'm looking for. Here I know this language, I can read it. I mean, this is also just explanations. Crossbeam. I mean, actually, I guess people use crossbeam. I should probably look it up. But I think last time I looked, it's just Q. Q. A poke-based garbage collector. I don't know what it is. Synchronization. I need a log-free map. Oh, skip list. Crossbeam skip list. This should have a lot of downloads. Of course, it redirects me to GitHub. $5 million downloads all time. That's great. Although not very active. Not very active. Type skip map and skip set. Data structures provide an interface similar to B3map and B3set respectively, except they support safe concurrent access across multiple threads. Those environments, I mean, I guess that's kind of what I need, and that's kind of what I should use, because Crossbeam is the most popular library for that. Okay. So let's do this cargo. Yeah, I can't settle. Wait, I should also keep this. Wait. Wait, that's not what I should be doing. This, here. Okay. Changes to crossbeam, skip list, skip list. Wait, skip map. It's called. Skip. Oops. Actually, can I just roll back to debug and default? Crossbeam, skip list, skip map. That should work, right? So skip map is pretty simple. Why is crossbeam thread scope and not regular thread scope? I don't like this. No STT, dev, okay, utilities, creates, well, I just need an array. A log-free vector. STC, okay, maybe STC was the right one. I think SCC did not support something that I wanted. Or at least did not support default. Hash map. Oh no, it does implement default. Okay, however. Okay, this one creates. Any word about benchmarks? No. Because does it really matter at this point? Spent like what? Yay, 1 hour looking at libraries. Entry access. Well, benchmarks should exist somewhere, right? Benches. Hash map. Okay, I guess, I mean, SCC maybe. I just changed my mind again, 3.3.1. That should be fine. So SCC hash map and SCC bag. What's wrong? LSP is dead. Yeah, right. This, we don't need this. Here. Ether sync. Could just name it ether and then ether async. Ether. Mutable iterator. Why not just use the iterator then? Well, that's just iter, and it takes a function. Okay. Is there a function that would take self from iterator? So like into iter. Yeah, no, that's pretty sad. But I guess it doesn't really matter. I still can't really destroy it properly. Key function takes key value, so underscore tackle. We just do this. Then we write expected bool, keep iterating. True. Oh my god, this. Oh my god, this. Oh, why? Why can I? Oh my god. That's annoying. Because I can't break out of iterations. Of iteration. Well, I mean, I could hack my way around it, like let mute result equals okay. If let err equals this false, else true. Or I guess I could just do return false instead. And then we'll do result question mark. Something like that. Or actually I could do, what I could do is result equals this. And then result is okay. Hi Kanye. Kanye. Thank you for the hydrate. So earlier Funky Waddle cheered some beats and my overlay, well, it did not crash, but it errored out and did not display much. Might just be me. Or might be on you. Hi, Kuku. Yeah. I should also do some things with that. Well, Kanye allowed me to blame him all the time for everything, so blame Kanye, right? Okay, so devs. What do I do with devs? Iter into iterator. Oh, there is into iterator. Where? For sure. You didn't say hi, did you? So hello. Okay, cannot move out. Oh right, we don't have intuiter now. I mean, I could do this. Oh, am I quiet? Well, I'm pretty quiet myself. Use it for this age. Minus start. Oh. What do you mean by starting a tone modifier with a minus sign? Okay, filters. I mean, I have limiter expander. Do I just need gain? I mean, maybe I should just talk louder. Threshold release. Why decibels have? I also don't know. Oh, right, we can. If you put a space there, we can. Which is weird. Because Twitch removes all white spaces from the edges, but you can put space, and then slash something, something. Anyway, expander, is that what I need? What even is an expander? Compressor, okay. I'm not very good at like audio stuff. Compressor, sure, let's add that. Probably before limiter. Or do I need limiter if I have compressor? And what is an expander? Well, noise gate, sure, I'm gonna keep it. Okay, compressor, ratio, threshold, attack, release, output gain. So now I should be louder. Maybe, a little bit. I guess limiter is always nice to have. Expander gate. Yep, fine. Like on the bar it doesn't okay, maybe it does go up. Okay, so this should be good. Oh, and here we go. Alright. Is this the overlay? YouTube check. YouTube chat does not update. It's annoying. Okay, so not an iterator. However, there is iter mute. Ah, we'll be back. Okay. Something similar to noise gate. Yeah. I also think it's something similar to noise gate. It also has a gate mode. I should probably rewatch the. I should probably rewatch the video that I recommend to everyone about doing the thing. About audio setup on streams, right? Oh, yes, that's not quite the best. There's a term mute, which takes mutable self, which is not what I need. Oh my god. Why is the a bag not it? Oh, I'm doing well. Except that I can't figure out which lock-free primitives I need and where do I get them. Okay, so this SCC, well, it has a bag, it also has a linked list and a set. I mean, linked list might be better. Okay, let's see. Atomic shared L, Q size, linked list, linked ref, guard, whatever, L. Is it tracked? Okay, sure. Head, L default, tail, shared L, shared new L, atomic shared null. Huh. Why are head and tail not connected? Oh wait, now they're connected. Ow. This is difficult and complicated. I mean, I can drain the bag, I guess. Bag. So bag is pretty much my only, the only thing that can save me. The iterator that moves out of bag and mutable iterator over entries of bag. So bag. So we could do pop all, I guess. After all. So sad I can't like look into it. Pop all. Initial and closure. Initial. Oh wait, does it? Oh, it's a fun mute. I don't care about initial value. Oh wait, no, I do care about initial value. I care about result. Okay, that is interesting. Although, is there a way to stop iterating properly? Result, result, and then how does people look? Fine. Right. Self stack pop all. Oh, under the hood it's a stack, which is the log-free LiPo. Well, I mean, I guess I could use the stack instead, or a queue. Hashcash, tree index, FIFO, LIFO. So stack should have iteration, right? Okay, there is obviously no way to access the docs for it. Stack HTML. Oh, that doesn't exist. Great. Okay, let's go into here. Stack. Here it is. Stack, push if. What? Pick, push unchecked, pop all, pop if, pick with. Well, this should have an iterator at least. Yes, it has, but it takes a guard. What is a guard? To read atomic share and keep the underlying instance pinned to this thread. Okay, so guard is like a mutex lock. Okay, sure. Yeah, let's use stack then instead of this bag. Although I do not care about the order whatsoever. To do unordered container will work better. Okay, so here, oops, we'll do for def in self defs iter guard. Let guard equals guard new. However, guards. Okay, so this should work. Now, for implementing it. Why is LSP like so wise? This makes me concerned. Let's see. SDD, SAA, SCC. Those great names are great. Oh wow. Okay, so Cogent and declaration I assume as well. So we'll have to fix many things here. Oh, many things here. So we need entry sync key. Key being name. Is it borrown key? No, it's not. Well, key is copyable, so I don't care. Now, so here and modify. This is gonna be panic. Panic unwind, that's great. Or insert oops. Value declaration. Wait, we need insert new one. Wait, right. We'll need to fix this. At the end. So here we'll create a declaration. Actually, can I? Can I actually? Can I actually do this like that? Match declaration. I mean, I guess I just add a match here. Well, function signature doesn't have display and will not have display because name. I mean, I do actually want that. So I want some shared data and some non-shared data between those non-variants. I guess it's fine without the name. Like my self kind. like that. Fill my charms. Signature. I'm gonna write f sig dot red. So it's gonna be red name opening parenthesis with red equals to this, name equals self name. And then for each argument, something kinda like that. Params iter enumerate. So it's gonna be ty name. If index is greater than or equal to, well, okay, awesome. Need okay here. So it's just formatting parameters. Right, f comma space here, and then here we're gonna just write name. Is there a name? If there is a name, we'll just move this basically up there. Write into f type and optionally on name. Wait, the name should be escaped already. So this should be optional string. And this probably should be a reference. Right. Refs, let's go. Actually, no. This is the reference to an option, so it automatically references everything. Okay, good enough, I'd say. Now we'll create a signature. I'm gonna move this down here. So this or insert declaration with name, create escape name, kind declaration, kind function signature. Okay, so params, we create params and then we iterate through all params. Don't care about index this time. So I can just get rid of that. Ty into name map create escape. So this takes symbol returns a string exactly. Yeah. Actually, copy it There's clone. To own. Wait, no, I don't want to own. I just want clone. Well, I just want to deref it actually. In fact, I just want that. And also, I can probably, instead of doing this, just do params.map. Ether map or into ether map name ty. Then just put this here. So then it needs this. Collect. Variable does not need to be mutable. Sure. So this shortened a little bit, but this appeared. Now code gen. We'll need to fix that as well. I was supposed to be working on arrays, but then I was like, no, let's rewrite everything in the backend to be concurrent. Yay. Okay, line. Everything. Well, it doesn't have to be concurrent, obviously. Well, it doesn't have to change at all. Just the insertion part. So self decals. Get, there's no member get now. Get sync. Oh my god, sync. Key reference. Yeah. So this gives. This returns an option, right? Option to an occupied entry. So sig is an occupied entry. Let's do remove next name kind. All right. So we'll do decal. Declaration kind. Oh, it's not work. It's create declaration kind. Function sig else panic name is not a function. Wait. Yeah, I don't need that. How often do you use let else in Rust? Where's my cursor? Here it is. YouTube check. Failed resolve. Declaration kind. Maybe I misspelled it. Likely. Okay, now signature. Instead of signature, the decal name. Not a big deal. Then for each param. Okay, right. Index, ty, and name, which I don't care about. And then this. So instead, defs is just push Well, yeah, we literally just push the code. That's pretty simple. Now, this should in theory work. No, it doesn't. Move out of the reference. Sure, then reference it. Does not matter. Else clause is useless. I know. Ignore it. It's gonna continue being useless for a while until we add constants and other items. Actually, type this or structs. Simple main ow. Ow ow. Forgot to close the parenthesis. Also the space. What? What was I thinking? Go to declaration stuff. Here. So this, and then at the end. So we wrote all the names. We'll write closing parenthesis and this thing. I mean, I guess I can just do this to cap it off. So this should look a little better. Also, did I... It's gonna be double semicolon, yeah. I did not remove it in the... Wait, where? Here. Escape the symbol to be a valid C identifier. Possibly does mangling. Okay, so this should work better. And let's do some doc stuff. So this is gonna be all definitions in no particular order. Now I can also parallelize the front end, that means, which is really easy. Map from symbol to a declaration. So what decals will we have? Types, type aliases possibly, functions, macros, no. Types, type alias functions. By types I meant structs, unions, enums, etc. And possibly external functions. I mean, that's just functions. Well, that's it. That's about it. Yeah. Ignore missing docs, because come on, am I really gonna document silent? Just ignore links. Allow. Because I mean, it's really self-explanatory. Yes, that function signature is absolutely undocumented, and declaration stuff is undocumented. Function signature without a name. C. Create C super issue. Why does super declaration not work? Create declare then. Huh? using type p types without a name. Okay, so type works. This does not. I do this instead. Does not work either. Oh, decoration. No, that works. Yes. No names. Return type. Parameter types with optional names. Yeah. Now, here. Name for the symbol. Escaped using read escape. The declaration kind kinds of declarations function decl function signature. As many links as possible. Wow. Okay, so missing dogs should not be angry anymore. For front, for backend, nap over. Nigel, you're gonna be terrified when you see the new backend stuff. It's now all asynchronous and using weird crates for this. Oh, not asynchronous, it's log free now. No way in the world am I gonna make an asynchronous backend for the compiler. No, I'm not dealing with async ever since the 2023 or something event. What does log free mean? So you remember the RW log of a vector for function definitions? Actually, you should probably have it. Yes, you do. Well, okay. Then, so in order to use it every time you log it, and then append to it, and then release the log, which is slow. So impl codegen, yeah, I mean, kind of. Point is, I could make it mutable borrow, but instead I made it immutable so that you could generate multiple functions at the same time. Now, I replaced it, well, that's just a backend choice. You can still use rwlog, obviously, but I replaced it with a log-free container, which means you can push to it without locking it, without forcing other processes to wait, which, I mean, logs were pretty short, so it doesn't really matter. And then I also made sure the declaration part is also asynchronous. Might as well rewrite and see no. What's wrong with my voice? That's better. Now, declare foreign function. What? Oh, right, that's Rust stuff, isn't it? So let's see. Rust, just front end. So codegen was already using asynchronous API. Now declare. So see this for loop. Now if I do items, bar items, that's gonna be better. So now it's gonna run, basically run this for loop in parallel, partially at least. Expected result, huh? Just add okay at the end. Now it's gonna be angry because impl back and does not implement. Okay, let's look at where was it? It's where it was codegen. So here basically did this, and this just returned okay. Yeah. Alright, the ref backend. Can just put an asterisk here, and no, I only need immutable access to it. That's the whole point. Now here it is no longer. Is it no longer thread safe? No, it's no longer thread unsafe. Or like, okay, what does thread safe mean? Hold on. Well, every Rust program is thread safe unless I use unsafe now. Like, point is, so Rust, basically in Rust, every time you have to have a type shared between multiple threads, you just make it an immutable borrow. Hence it's the name shared borrow, shared reference. And underneath you either use rwlog, anything else. Well, yes, but it is pretty safe. And dude, it is like, hold on, this one. It has 29 million downloads all time. Do you really think it's bad? So this should now be better. What? Because the appears within the type mutable reference. Oh right, because this does not need to be mutable. User from all C++ users trying Rust for 5 minutes. Then and googling Rust most unsafe back. And for 5 minutes and then googling Rust most unsafe. Come on. I mean, it's now better. Now declaration can be parallelized, so you can declare millions of functions in parallel. You're still a little sleepy. Wake up! Okay, it's fine. Did we do this for code gen part? Wait, this is the wrong code gen. This code gen. No, we didn't. Because backend is already requiring it, isn't it? What? Backend, impl backend. Oh, it's definition backend. Oh, right. Wait, right. Hold on. I'm just gonna do the same thing here. And it's just gonna work. Hold on. Here. Unused result that must be used. Come on. I'm just gonna copy everything from CodeGen at this point. This is the wrong one. Did I just unwrap it? I did. Now, if we run the code, it should be parallelized, more parallelized. One warning, two warnings. Oh, that's great. And now, I mean, sure, it doesn't matter. So the code we generate is still as good. Just erase. Because this just doesn't work like that yet. Well, yeah. But it's likely you're gonna want to use that. Although, actually... So, like, in order for this to actually be worth it, you'll need it to be... you'll need to compile millions or billions of functions. I mean, actually... Well, it's probably worth it. It probably is. Point is, the change I made in the API is that now frontend... Oh, wait, now... Is that now declaration backend also must be asynchronous. Then enforce it with types. What do you mean? And force you to use lock-free types with types? No, I don't care about your implementation. You can use lockless. Like, you can call a different backend, I can't enforce it. Like, I can't force CraneLift to use it. Anyway, let's commit this for now. We did start to work on race. Free and improvements. So this is lock-free declaration. And parallel declaration. Good enough. Now I mean, yeah, but like, again, you don't you don't dig into CraneLift internals and say, oh, this uses something lockless, lock-free map. I'm gonna have to use it now. No, you just call a function, declare function. You just call a declare function, and it uses the map under the hood. Just like with Oracle, you don't even have to have those maps. You can store the types any way you want. Maybe you're not gonna store it, maybe you're just gonna receive declaration, emit it somewhere, and not even store it. I store it because I need to. Because I'm gonna have to reference it later. It won't even be under the hood for Oracle for backend maintainers or frontend maintainers. Yeah, I don't really understand what you mean here. So, for backend maintainers, if you're maintaining a CraneLift backend for Oracle, then you will not have to worry about CraneLift internals, because that's basically just translating Oracle calls to CraneLift calls. And for C backend, I just decided to use lock-free structures, which I wanted to use for a long time. You could see the comment, replace this by something lock-free, right? For like other backends, for like from scratch, more from scratch like backends, like C backend or raw assembly backend, Well, obviously you backend maintainers will worry about log-free stuff or just use read-write logs on vectors and stuff or mutexes. But that's only the backend maintainer. Like API change here is only in the fact that declaration backend is now the same as definition backend in terms of in terms of parallel parallelization. Okay, so now more interesting part. How can we compile tuples, generics, and other things to C? Just kidding, we won't. Well, we will start on that by starting to work on arrays, because in C, arrays will require structures just like generics and everything else. So basically, array is generic. So basically, what can close all of this? So basically, what we want is to implement std : array in C, because this is generic. This is basically just a generic array. It's a struct wrapping array, because C array decays into pointer, which is annoying. Okay, so how it went, and then I looked at declaration. I looked at list of declarations in the C backend. I was like, okay, we'll need to add generic stuff here. Oh, this could be parallelized. Why not we spend what, 2 hours on that? More than 2 hours. Now, what do we need? We need declaration stuff. So now we have the declaration struct, which stores a name and kind. Complicate everything, yay. So, imagine we declare something generic, and then we'll need to track uses of generics. Okay, so yeah, we need to record uses every time. That's also gonna be something log free likely. So yeah, it's gonna be a little bit tough to structure, or I guess to think about. So where we convert types. Well, first of all, we convert types somewhere in declare in ty. So this from function, I'm not gonna cut it anymore because arrays, because of interning and stuff. So impl backend, create backend, append convert type or call type. It's gonna take self reference. Reference is immutable because it must be. Convert or code type to type. Yep. This should work right. It does. Now just return type. We'll just basically move this here, except that now we have access to backend. Alright. Why cool? This is type, this is type, this is type. Export C. Something like that. Now I'm gonna have to get rid of this. So type from, expected type from the reference type. Oh wait, no, it's gonna be self-convert type. What's the difference between type foo for all? Oh my god, what is this? In Haskell. For all A to A and type foo A. Well, with for all might be syntactic sugar, but I think with for all you don't expose generic parameter. Like in Rust you can do impl or for, like Rust has for. Did you know that Rust has for T I don't know, fn something xt. I actually don't know if it's gonna work like that. Yeah, no. Hold on. I'm gonna try to think of an example. Yeah, probably for generic will not work. But like point is, Rust has force, and they are widely used for lifetimes. I just can't think of an example. Kind of first foo is asterisk, whereas kind of second foo is asterisk to asterisk. Huh? Why? Okay, I don't understand Haskell to like ramble about it enough. Oh right, this also should be a reference. Now, by converting this, we have let's search for where it was used now. Actually, I could just do this right. Ty equals self backend convert type ty. This should work, right? I'm starting to get hungry, so the stream might not last for much longer. So should I? Yeah, I don't know. Move my microphone closer, cause like it's far. Is it better? I don't know. Kanye also was there, and we did a compressor, so I should be a little louder, maybe. Convert type. Yeah, now. Use variables, yeah, I don't care. Okay, so this should now compile. Add reverb. You're kidding me. Okay, I know what reverb is. I mean, I can try. Just for fun. Wait, where was the filters? Filters. Is it even there? I don't think OBS has reverb without plugins. Equalizer, move, compressor, expander, gain, invert, move, action. What even are those? VST2 plugin, maybe? Yeah, I don't have VST2 plugins. Yeah, that's pretty cool. I mean, like, people use OBS for recording, like, music instruments. Imagine I had a guitar, I plug it in, and in OBS I set up an audio source and just add VST plugins on top of there. Like, sure. That's valid. Now, what do we have? We need a race, right? we need to declare stuff. All. So we're gonna have public instances, which is gonna be an SCC, obviously. A hash map or a hash cache. What is a cache? Oh, yeah, no, we need a map or an index. So hash index is like read, tailored to read. I guess I need a hash map from what? From parameters, from generic params. Let's just imagine that exists. To, yeah, to what? Oh, okay, no, we need set. We need a set of generic instance. So a generic instance could either be a tuple, which, so this comes after decals. Oh wait, oh my god, the order, the ordering is gonna be annoying. Right. Should I think about the order now? So first we do decals, right? That makes sense. What if decal depends on another decal? And then like other things. Well, no, I still need to sort them, right? Which means, or either sort or like keeps ordering initially. See, I can topologically sort declarations. Then definitions do matter, the definitions do not matter. And instances are pretty much declarations, but, well, I mean, instances should be bound to their respective declarations. That's what I need. Can I mutably get a decal? Wait. That's kind of what I need. Hold on. I wanna check self decals. Get sync. Key to do, I don't care. So we get it and then wait. So this returns an occupied entry. Does occupied entry wait. Does it deref into mutable? That's the question. Well, there's get mute. It needs mute self. Well, I have the own thing. I assume I can. Oops. Well, if I just do that, ignore warnings. Underscore equivalent ISTR. Okay, that works. Oh wow. Okay, so I can actually put instances into decal. Second foo becomes concrete after a type is explicitly applied to it. Oh, right. Well, I mean, different. They are just different. They're just not the same. I assume. To be honest, I have not yet hacked Haskell interpreters, so I can't really tell. But you know, once I do that... How? Well, I mean... just deeper. I don't know. So... First one is... for all A to E. Why is the first is kind asterisk? It's still a mapping. It's just that it infers type. And the second one is well, basically the second one is a function that takes a type and returns a value. And that's just different. I don't know why, but this. Whatever. YouTube check. Actually, I should probably like do something with it, because YouTube does not update like even if I hover over it sometimes, which is really annoying. Okay, so if we put into declaration pub instances hash set or something, does it make sense? Imagine this being SCC hash set. I mean, log free hash set. I mean, could be. Could very well be. Because this is bound to declaration. All instances of this vehicle if it is generic. And then we do instances of arrays and tuples separately, basically. So this is a hash set of what? I mean, kind of want to put symbols here. But no, it's generic. This SCC. So see, I will not use default here, I will use new because I like new. I like the name new. Okay, so generic params. Yeah, we're doing generics. So this process is called monomorphization, I'm pretty sure. Although I should check. Monomorphization. Yeah, obviously I'm not able to type it properly. In programming languages, monomorphization is a compile-time process where polymorphic functions are replaced by many monomorphic functions for each unique instantiation. It is considered beneficial to undergo the mentioned transformation because it results in the output immediate representation have specific types, which allows for more effective optimization. What does undergo mean? Like, I feel like it's such a simple word which I just don't know or do not understand or something. What is monomorphization with context to C++? And then Rust. Go through. Okay, makes sense. Literally. Monomorphization in C++. First example. Like, actually, why? I mean, yeah, Rust is very easy to explain generics in, I assume, and also types sometimes. And like, many people know it. Just like C is also efficient at explaining programming concepts outside like simple ones, or where you don't need like generics and stuff. But the question is specifically C++. Like, you go to a forum, you ask, how do generics work? Oh, how do templates work in C++? And you get an answer with Rust code. It's like, here you write a function in Rust here, like that. Yeah, you don't use C++, you use that. Anyway, So that is monomorphization called. That is called monomorphization. In our case, we never monomorphize. This is like we never do monomorphization. Instead, we store original function and then create instances by appending additional lines of code, basically. I feel like I want to make arrays generic, like generic. So it would be simpler as so I would literally create a struct array t s const s inner t array with array ts. I literally want to make this in C though, because C doesn't have proper array stuff. Imagine how weird it would be. Like you would transpile C++ and it's like a function takes an array, and instead of transpiling to a function taking an array in C, it would transpile to a function taking a struct that wraps an array. Yeah, calling conventions are difficult. I will definitely need to revisit calling convention stuff and naming convention stuff. So basically ABI. Let's go to cgenlib. To do ABI. Oops. A big to-do block. Look at my mouse. What's wrong? Okay, my mouse is actually acting. It sounds something's wrong with it. I noticed that it like was jumping more a lot of the time, but now, like, what am I supposed to do with that? It's pretty annoying. Okay, enough of that. Here it is. Here, you can see it works. Kind of. Well, now it's stable. Was it on the edge or something? Well, right now it's on the edge, basically. Is it batteries are bad or something? I don't know. I remember like I was doing some Minecraft stuff. And I was walking and it just woo and looks up and like also turns 180 degrees and I was like, what? What's happening? Okay, so yeah, instancing. Imagine if we create an array decal, make it generic. I mean, at this point, I could literally just do generics instead of everything. Struct array. Well, instead of this, I could probably use a vec of generic param. Oh, and a generic param would be a public enum. Also, hash set cannot be used as a cannot be anything. So a generic param would either be type type and then it's well generic param instance is either a type which is type or value which is oh well sure. Okay, so we can't do eq partial order and hash. This has partial eq. Why? But not eq. Weird. Anyway. So generic param type, generic param value. Actually, we don't care about generic params. Actually, I don't really care about generic param here. I can just do a string. Vector of strings. Yeah. Yes, whatever. Okay, so when we do generic stuff, I can wrap it in a macro. Well, what if it's generic of generic? Well, yeah, we flatten generics first of all. So we flatten generics, then we wrap it, like we did before, in a macro. So now somehow I need to put a backslash at the end of each line. Wait, that's function decal though. Wait, that's function declaration. Do I need to separately generate? Oh my god, no. Oh my god, no. Because like function definitions. Should I merge them? Because yeah, sure, definitions should be generated separately from declarations and should be generated at the end, but for generics that's not the case, for example. And for generics, well, many issues arise. So I don't know. I think we'll figure it out next time because I am pretty hungry. 3 hours in. Yeah. I mean, it's not quite there. Not quite there. Actually, do I have to make structs valid before I do arrays? I don't know. Or should I just hardcode arrays to be just maps or just sets of like types, and then I just generate them at some point? Well, yeah, that's easy. Yeah, let's get rid of this for now. Might actually do that. System. So this is gonna be instances of array types. About arrays. So this is gonna be a hash set of a type and use size for count. Okay, I should actually use type here because it's like useful. So in Cogent, for example, I should use create type. Right now. Well, Cogent is short actually. And then give up on your lambda calculus lang. Write a type system capable of parameterizing polymorphism. What does this mean? And type constructors, so you can write all types in the language using not number though. I mean, you could settle for a non-polymorphic type lambda calculus which is built on top of existing types. Should be called puts pretty useless types. I don't know if you can do number 2 because I don't really understand what it means, because it's pretty on the edge. Parametric polymorphism. Type constructors. I do not remember Haskell. Okay, I do remember. I do understand the second one part. It's just generic, basically. But first part is you infer the type. Like at the end of the day, you're gonna get rid of types altogether with charge encoding, and there's gonna be nothing to infer, nothing to do with it. Type system capable of parametric polymorphism, type constructors. So we could write that. I don't even know what how charge encoding was supposed to work with that. Well, at the end, you will only have one type. You're gonna call it type, and then you're gonna say, well, this type is a type of a type. And like, and something like that. And it's just gonna be that, basically. Oh, what? I mean, okay, makes sense. Although, can I get an example in Rust? I got type constructors for polymorphism, parametric polymorphism. I know you can't do this. Anyway, not possible in Rust, fortunately. Well, actually, it kinda is possible in Rust. Kinda, partially. Well, if A implements at rate, you can just use impl rate. Or, you know, actually, let me try. There's another way, which I don't think you can. Type foo1 of A equals let's just use fn pointers instead of traits to simplify it. I don't think it's gonna work, but like, let's see. On the left, type parameters can be used in this context. Sad. So sad. So sad, so sad. Anyway. So arrays, then, when we convert type, array type, so we're gonna do self arrays insert thing, returns an error, I don't care. So insert thing key, which is a type and use size. Well, we already have type and size. That's exactly what I want. Type either lr equals a case. Oh, what? So how did actually it's a mode appeared. Okay. So either L or under is for a something. Where does this parenthesis end? Oh my god. To opening, to closing. Okay, something. What is that? R equals. Okay, let me just switch here. Case left returns. So it's something that takes case left and returns say, oh, what? So I assume that is carrying. Can you write this without carrying? please. If this is what I think it is. Although with carrying it kinda does look nice. So I think it's just an either type is a function that takes two functions, case left and case right, and returns, depending on which one, it returns a common type. Okay, makes sense. Oh wait, you did send it twice, I didn't even notice. Oh, that's why the space is there. Okay, makes sense. Function left LR left item L colon either LR return case left case right case left. Okay, yeah, I kinda do understand what you mean. That's pretty cool. Functional. Although functional. Which I don't really like that it's functional. Deriv that. Clone that. Wait, so, generic system is gonna look similar. Reach Y size. Symbol. Of the equality. Left to the equality is the dilemma you're having now. You'd prefer having all of them on the left. What? Lesser features to implement, but you had a small hiccup when with writing that implementation of plus for natural numbers in that system. What? Okay, so the dilemma you're having is whether to put A on the right or on the left of the equality sign. Oh! Obviously on the left. Oh wait, yeah. Wait, no. Oh, makes sense. No, you shouldn't. Well, I mean, okay, you could. It's like, I'm gonna tell you a mystery. Generic types do not exist. Generics are just wrappers around anything that apply a set of types after monomorphization. So basically you have a set of symbols, you can wrap them in generics, and then when you monomorphize it, you duplicate this set of symbols n times and just apply those generics inside. So generic types do not exist, and the only reason they do exist is because in order to so that you can easier refer to them. Yeah, and lately people stopped. People started introducing. Well, lately, needs to code all that stuff. So lately people started to discard the fact that generics are constrained to types or functions, because type inference is able to figure that out without having to provide the types. Anyway. So we're almost there with arrays. Alright. declare mode. Instances. Now, so this should at least compile. But yeah, I do need to ignore this result. Okay, now. So this used, yep. Now we need to just declare it. Which means here we're gonna do for does this work like that? Interesting. Yeah, we still have to use a function. Find mute of reference to key. Okay, and returns a bool. Obviously continue iterating. Oh right, I need to do the result thingy. That's actually pretty nice. So okay, so we're gonna do struct. So array is a tuple of type use size. Code of stuff in stdlib. You're prepared to see very complex code, but wasn't prepared for this. Core convert. Wait, what is core convert mod rs? Yeah, none of us prepared for that. We're ready for that. The identity functions. Those things are important about. Like, look at the document. I mean, I know why it exists, I guess. Something equivalent to a closure, since the closure may coerce X to a different type. It moves the input X pass to the function. Strange to have a function transfer back to the input. There are some interesting uses. To do anything in a sequence of other interesting functions. Why is it an std convert? I mean, sure, I guess. Manipulation of identity. Well, basically the same all the time. Filter map. Oh, that's so useful. I mean, Flattern exists, but still so useful. Reference to reference conversions. Oh, yeah, I see what this module is now. Anyway, so let symbol. I'm gonna remove the. Once we start using generic system, I'm gonna remove the annoying part here. Or what was it? I'm gonna remove. Yeah, I'm gonna remove the duplicated code because yeah. Well, I mean, it's still gonna be duplicated, but it's gonna make more sense. Anyways, so where was it? Here. So this should cover it. Although uses of an array, well, I mean, array is just a wrapper type, and every time you want to use it, you well, you just access the index. That's the only one, right? So index projection on array type, on a value of type array, is gonna be a little more complex than regular. Yeah, that works. Okay, look at that. We've got arrays, let's go, they should work. In functions, there is never type abstraction, it is always polymorphism, at least in Haskell. What is type abstraction? Type of any generic function will have a for all preceding its type annotation. Okay, interesting. Oop, that's not what I wanted to press. I wanted to press this. Actually... Wait, why is it working like that? Whatever. Erase. So I'm gonna change backend stuff soon, but Nigel, you can take a look at it if you want. The explicit type application, like in type foo A to A, is type abstraction. Okay, I guessed it. Now, I think that's enough for today. 3 hours 16 minutes. I mean, I could probably stream for longer, but like, I'm a little tired. It's a little cold. Or should I? What time is it? 3 p.m. Oh wow, I did start late. Despite being like early. By the way, we hit the bits goal. Let's go. Step abstraction. Okay, so yeah, you're interestingly enough, you're perfectly on theme because making arrays means making generics. On topic. Okay, so we're gonna have to do structs at some point. But I think I'm gonna delay this for a little bit. I don't know about function bodies. I might try putting them inside of declarations. I might. You should just make puts type system which can't even have arrays because no type constructors. I mean, I don't have type constructors and I have arrays because I hard-coded them, right? Okay, tuples next. Oh god, more. This is more of that, more of the generic stuff. You'd rather do quit programming than do that. See, I could try tuples. Why is it so cold? Could try tuples. Or could try moving on. Because I want structs to do generic stuff. Well, I mean, tuples are still useful, right? So I need... Ideally, what I want is a common interface around what is it called? Interning types. So type system is complicated, obviously, and so backends should be able to. Well, at this point, why is it the responsibility of the backend? Because declaration. What's interning? What do you mean you don't know what interning is? Like, imagine you have an intern pool, and then so you get a string, for example, hello. You put it into the intern pool and return its number 0. Then next time you get a string, you check if it was hello, and if it is, then you return the same number. Otherwise, you put it in the intern pool and return a new number. That's basically interning. So when you have multiple instances that refer to the same thing, you get the same ID. Basically, kind of something like that. Yeah, now, what should I do? ID system. Oh yeah, people call stuff internars. Orco uses interning for identifiers. You saw the symbol, which is iString, which is intern string, basically. But that's like a global interner, so it returns a pointer instead of an ID. And yeah, you don't necessarily have to use IDs. You can return the I mean, you can't really return instances. Point is that intern pool. Oh my God. Point is that intern pool takes objects and makes sure that only one instance is there somehow. Most of the time it returns IDs, which are the same for two different things, or pointers to those things. Yeah. I guess that's kind of it. Now, you prefer pointers? Well, it depends on the use case. Sometimes IDs are more useful, or whatever entity would be identifying it. For example, in my case, interning would return a symbol, which is a string. Well, I mean, interning a type would return a symbol that refers to the type, and then I will declare or define the type single time, and then use it multiple times in very different contexts. Now, tuple system. TypeScript compiler API also does that. Well, kind of obvious, I guess. Did you look at TypeScript compiler API? I didn't even know that existed, honestly. So let's look orcolib. So if we take a look at type, if I add a tuple, only purpose is to be interned by the backend. And then we'll do tuple. Or, I mean, kinda something like that. You were thinking of transpiling the lambda calculus to TypeScript abstract syntax tree just for type checking. Since TypeScript already has recursive types. Type foo. Well, that's a good idea, isn't it? You could use Orco, you know, to transpile it to any language you want, as long as backend for it is gonna be at some point created. Okay, so do I need tuple or should I do something different? I mean, let's actually take a look at C++ tuple. Because it was given done. Sure, but like type checking with TypeScript. So point is you transpile it to something, you type check. Orco will be able to do type checking, maybe. Okay, let's see. Yes, that's exactly what I expected it to do. Variadic generic arguments. Do you think I should support that? Do you think I should support variadic generics? I did not think it's gonna be even more weird and complicated. Like, only reason backends should support generics is monomorphization. Anything else can be just syntactic sugar. You didn't use it because there doesn't seem to be a standard way to give TypeScript compile API the input directly as AST. It expects file names. TypeScript compiler. Okay. Oh. Interesting. Anyway. So, yeah. We'll need to think about that, but I think I'm gonna end there. Pretty tired. Let's see who we can raid. Me. Raid. I have to check just in case. Captain Anos is there, but just in case, maybe somebody. There's also compiler stack. Oops. Search filter compilers. None of your full streamers are alive. Besides things got one. Oh, none of my either, or else it would show the following thingy at the top. Well, yeah, up to you then. We could raid Captain Anosa. Nice, 13 squared. Username Captain Anosa. You can use the raid browser, I'm pretty sure. Well, you should be able to at least. Should also probably end the beats call because, well, it ended. Username. Ah. Like, I can raid at this point myself. Anyway. Thank you all for joining. I will see you next time. We'll hopefully do generics and other things. See you. Bye. Just actually open the stream. Bye.